Okay, so for today we will continue on the integral and also derivative control. Okay, but before that, I would like to we try to do the other one tutorial on P. Hari tu kita buat up to tutorial 2, betul tak? Ke kita buat tutorial 1 sahaja?
Sampai tutorial 2 je.
Sampai tutorial 2 sahaja kan? Okay. Okay, macam inilah kita conclude first the proportional control and then we continue with integral and derivative. Okay, for the first tutorial, you get the based on the equations method and also quick tuning chart method, you can say that your process is shift to the left, right? Betul tak? When the PB is increasing, then you can get the new response shift to the left. Shift to the right. Betul tak? For the tutorial 1.
Betul.
Okay. So from that we can see that the higher value of PB it will slower down the process variable, which is PV lah. Bila PB higher, PVU akan semakin slow. Betul tak? Kalau kita tengok kepada equation method, we get the slower process response, and from that we know that the process will shift to the right. So that's mean bila kita increase the value of PB, it will cause for the equation method, when we increase PB, it will cause the MV to it will slower the action of MV, and from the slower action of MV, it will slower the process response. Betul tak? Itu kita bincang macam tu. Okay, for tutorial number 2 pula, from here, sama, PB also increase, right? I tak tulis dekat sini tapi in your book mesti dah ada kan? You dah catat kan hari tu? Wait Tutorial number 2 kita dah buat kan?
Sudah.
So sudah, maksudnya you tahulah kan? For tutorial number 2, we get that PB increase. Betul tak?
Betul.
PB increase, then increase of PB make action of MV slower. Ini. And then because of MV is slower, the process response would be slower also. So the process, the new process response will shift to the right. Ini yang you dapat kan?
Betul.
Okay. So we try to conclude Sekejap the conclusion is at here lah. Yang ni yang you dapat. Bila PB you increase, your PV would slower. So the relation between these two is inversely proportional. So when you decrease the PB, your PV would akan
menaik.
Yes, menaiklah faster. So this is the the relationship between PB and PV. Kenapa we need to know the relationship between PB and PV? Because when we do tuning, the main concern is our process response itself. You tengok dekat sini When we do a tuning, we focus on the process response. So based on the relation that we see from the equation and the other method, which is tuning chart, we can say that when we increase PB, it will shift the response to the right. So bila you nak buat tuning, you akan ingatlah, oh bila you increase PB, dia akan ke kanan. You aim your process response tu lebih cepat. So you tak boleh lah increase the PB. That means you kena decrease the PB lah. Boleh faham?
Faham.
Okay, so for today, we will continue on the integral time. So, okay, we try to do the two tutorial at least. I take one example for the increasing, the other one example for decreasing, so that we can see we can conclude the relationship between I and PV. Kesemua controller yang ada, kita akan relate dengan process response. Sebab the main concern sekarang kita nak tengok process response when we change the value of P, I, and D. Okay, so let's have a look on tutorial 5. Okay, this response is for the water flow rate control. So this water flow rate control, we made a set point changes from SP1 to SP2. Okay, the original value of PB naught is 60%. The integral time is 4 seconds. So after we do the set point change, the new value of PB is still remain the same, 60%. The new value of integral time is 8 seconds. So we can assume that for this process, assume that process response PV is process variable is directly proportional to manipulated variable. Okay, so we try to do method 1 first based on equation. Okay, first thing first, we need to compare old and new controller setting. So the old is 64 and 4. So the new one is 60 and 8 lah. So, okay, based on this data, we observe the changing parameter. We can see from here, only I is changed, right? Betul tak? So
Betul.
yes,
Betul.
okay. So we underline yes for I, no for PB. So the change here, the adjustment here is increment order or decrement order from 4 to 8.
Increment.
So increasing lah dekat sini. Okay, step number 3. Okay, we need to relate I to MV. Okay, based on the equation 3.11. Okay, kalau you lupa, kita tengok balik equation 3.11. This one lah, 3.11. So the relationship for this equation, we can see here dekat sini. So MV dengan integral is inversely proportional. Okay. You tengok dekat equation ni pun, you boleh nampak MV and integral is inversely proportional sebab integral is denominator, this one. Okay, go back to the tutorial. Okay, so for the when we increase the value of I, makes the action of the MV slower or faster based on the relation tadi. Yang MV is inversely proportional to 1 over I. So when I increase, MV
Decrease.
decrease or slower lah, the action is slower. So from MV, okay, we can determine, we can evaluate the effect of PV based on the relationship of MV to PV. So MV to PV, stated here, PV is directly proportional to MV. That means MV directly proportional to PV. So if MV decrease or slower, PV would
Decrease.
decrease or slower lah. Inilah. Okay, number 5, you need to draw the change in process response. Select one that match step 4. Okay, so because when MV slower, the process response slower. So slower process response yang ni lah. You can get the answer directly lah. Slower process response cause the new process response shift to the right. So based on the graph, you boleh lukis macam ni. Lukis the same shape tapi dia shift to the right. Nampak tak? So dekat sini you can conclude that when you increase I, your PV so when you increase I, your PV akan jadi apa? Kat sini.
Decrease.
Yes, decrease lah. Based on the relationship ni. Okay, kita ada one method which is based on quick tuning chart. Ini number 1 sama 60 dengan 8 for the new I. So the change is occur at I only. So underline yes for I, no for PB. So the change sama, increase from 4 to 8. Okay, so based on this graph, okay, which chart you want to choose to evaluate this graph? Ingat lagi tak kita ada a few chart hari tu? Kita ada chart 1, 2 and 3. So which chart you want to choose?
Chart 1.
Chart 1. So you choose chart 1. Okay. So for the 4th step, you need to match step 2 and 3. Okay. So sekarang ni you increase. You increase, you refer to chart 1. Okay. I increase, what would happen to your process response? Refer to this one.
To the right.
Yes, shift to the right. So method number 2 is quite simple kan? You just tengok je chart tu punya movement. Then you can get the answer. Okay, so number 5 you need to draw the change in process response. Sama lah macam tadi, shift to the right lah. Okay, so this is the conclusion for the first exercise lah. Okay, now we try to see the other example for decreasing. So this one lah. Tutorial number 7, decreasing. Okay. So tutorial number 7. So this one is for the water flow rate control also. The original value of P and I is 60% and 4 seconds. The new one is 60% and 3 seconds. Okay, so kita masukkanlah the value 60 and 3. Okay, the change occur at I only, sama macam tadi. So the change is decreasing or increasing?
Decrease.
Decreasing. So based on the equation 3.11 tadi, kita dah tahu MV is inversely proportional to 1/I. So when you decrease the value of I, the value of V would
Increase.
increase lah, faster lah. The action is faster lah. Okay, so you can take this one. Okay, when we relate to MV to PV, kita tengok balik MV to PV. Dekat dalam soalan dah bagi hint, assume that the change in process variable PV is directly proportional to MV. Okay, so MV directly proportional to PV. So kita tahu the action of MV would faster. So when we increase MV, PV will also increase. So you will get a faster action and you will get a faster process response. Inilah. Okay. So from here, you choose faster number 5. You need to draw. Before that, you need to select one that match step 4. So you tahu from step 4, your process is a fast process response. So you just take one. Okay, based on this, for the faster process response, the new process response will shift to the left. So you kena draw balik dekat sini. Nampak lah. You kena draw ikut dash line ni. This dash line basically shift to the left. With the same shape dengan original shape yang diberi. Boleh nampak?
Boleh.
Boleh Okay. Method number 2. Okay. Masukkan value tadi 60 and 3. Okay, yang ni jawapan yes for I, no for PB. So direction is decreasing. Okay, this one you nak guna tuning check yang mana satu?
Satu juga.
Satu juga. So tuning check number 1, bila I you decrease, you akan dapat
Shift to the left.
Shift to the left.
Shift to the left. Yes, the shift to the left basically dia sepatutnya turun dan bila dia makin kecil dia akan ke kiri lah. Mana tadi? Ni. Okay. So same step as before, you need to draw that process response yang shift to the left lah. Okay, dekat sini you can conclude that when you increase your I, your PV akan decrease. Decrease your I, PV you akan
Increase.
Increase. Okay, so go to conclusion. Conclusion, you dah buat conclusion lah dekat atas tadi. When I increase, PV decrease. When I decrease, PV increase. So basically apa yang you buat tu sebenarnya you nak evaluate. Bila you tukar je value of I, apa jadi dekat PV. Boleh faham?
Boleh.
Boleh.
Okay. Yep. Okay, now we continue on the derivative pula. Mana Sekejap Okay, this one lah. Okay, now we try to do the evaluation of derivative time towards PV pula. Okay, we try to do two example. Okay, first one we do tutorial 9. Boleh?
Boleh.
Boleh. Okay, so okay, this is the process response for the temperature control. Okay, so the original, the old value of PB is 8%, I is 400 second, D is 100 second. Okay, for this derivative evaluation, the PB and I is remain the same. The change is occur at D only from 100 second to 150 second lah. Okay, so you boleh tulis lah dekat sini. The first step sama je. 400, 150. So the change occur only at D. So the rest is no lah. Dekat D saja, yes. Okay, so the change direction is increasing or decreasing? Increasing. Okay, so from here, okay, kita tengok balik equation 3.11. Siapa ingat relation between, kita tengoklah, you all yang tengok. Check balik. Relation between D and MV. Directly proportional or inversely proportional?
Directly proportional.
Okay, so MV directly proportional to D. So when we increase the value of D, MV will go faster or slower?
Faster.
Okay. So MV to PV, kita rujuk balik, assume that the change in process variable is directly proportional to manipulated variable. So definitely MV increase, PV also
Increase.
yes. So so we get the faster process response lah for this case. So for the faster process response, the new process response will shift to the left. This one lah. So to draw, you can draw a graph yang shift to the left. Inilah. Okay, so we do based on a quick tuning chart pula. Okay. Masukkan balik step number 1 ni. A 400, 150. So the same thing, PB no, I no, D yes. So direction is increasing. So chart mana yang you nak pilih? Chart 1, 2 and 3 ke?
Cawan juga.
Sama kan? So tengok chart 1. Kalau D you increase, apa jadi?
Yeah, shift to the left.
Shift to the left lah. So draw the change in process response. Lukis balik atas ni. Boleh?
Boleh.
Okay, next kita cari satu lagi. Example yang menurun. Yang ni. naik juga. Okey, yang ni menurun.
Tutorial 11.
Tutorial 11 lah. Okay, so for tutorial 11, this one is for temperature control. This response is for the temperature control lah. Okay, kita ada di sini PB, IND, 8%, 400, 100. Okay, the D value is dropped to 75 second. The PV is directly proportional to MV. Okay, kiranya bila you dapat soalan, you must underline the main point lah. Dekat sini dah bagi yang ni, and then this one and this one lah, dia ada main point dekat dalam soalan ni. Please remember, dalam soalan you tak diberi garis putus-putus ni, even for the SP ni pun you tak akan dapat. You akan dapat the original process response punya figure sahaja. Okay, so di sini kita start dengan equation based on equation 3.11. So step number 1, the new one is PB and I remain the same. The D is decreased to 75 second. So this one, PB no, I know, D yes. So 100 to 75 increasing or decreasing?
Decreasing.
Okay, decreasing. So D to MV, dah tahu tadi kan, D proportional to MV.
Yes.
So if D decrease, MV?
Decrease. Slower.
Decrease.
Okay, slower. So MV to PV dalam soalan dah beritahu directly proportional. So MV slower, we will get the slower process response. So for the number 5, you need to change. Okay, and also you need to tick this one. So slower process response will lead to the direction of the process shift to the right.
Right.
Okay, then you lukis lah. This one. Mudah je kan?
Mudah je.
Bagus. Boleh, nanti you boleh score lah this part.
InsyaAllah.
Okay. Based on tuning chat. Okay. Directly bagi answer. You dapat apa?
Dapat tuning chat 1.
Okay, tuning chat 1. And then, based on tuning chat 1, your D tu bila you increase, dia punya pergerakan tu,
Shift to the right.
Increase the
shift to the right lah. You boleh tengok je, I buka balik chat 1. Boleh nampak kat sini lah. Dia bila D tu lagi greater than D naught, D greater than D naught, sepatutnya shift to the right ke left? Oh, tadi dia menurun. Okay. Dia menurun. Bila D less than D naught, dia akan shift to the right lah. Betul lah. Sebab sekarang ni, your case is decreasing kan? D decrease. So, the PV tu would decrease juga. Bila decrease maksudnya slower process response. And then it will shift to the right lah. Boleh faham?
Boleh.
Okay, can we conclude? So the conclusion is D increase, PV increase, D decrease.
PV decrease.
Okay. Okay, so ada apa-apa soalan tak untuk that one?
Tak ada.
Tak ada.
Tak ada Okay, kejap let me see your lesson plan. Okay, kalau ikutkan this week is week 11, you will do PID tuning. So based on the set point and load disturbance. Saya rasa I dah cover lah untuk this week. Wait, let me share your lesson plan. Okay, so for this week, I already teach you on the PID tuning, which is hari tu pun kita dah belajar berkenaan performance test yang kita buat tuning rules tu kan. Yang tu daripada optimum control setting. For today pun kita dah try to do a tuning based on the P, I and D. And we see the effect of process response. So up to here lah kita dah cover. Okay.
Okay.
So ada masa lagi ni. Wait let me share back. This one lah. Okay, nak cuba tak kita buat yang ni? Advance punya.
Nah.
Okay. Okay, so let's see first this one. This one basically sama je macam tadi. Kita ada tukar the value of PB from 40% to 80%. Okay, you nampak this is 40% to 80%. So PB yang berubah sekarang adalah increment lah Okay, the conclusion that we can make bila PB based on yang tadi lah. Bila PB increase, our MV would decrease, our PV pun akan decrease. Kan? Betul tak?
Yeah.
Okay. So, kita boleh conclude dekat sini. Okay, an increase in PB make the controller action slower. Okay, so since PB is directly, since PB is inversely proportional to MV. So a slower action of MV will result in a slower process response. Okay, ini apa yang you tahu tadi lah, yang ni lah, this one. So since MV is directly proportional to PV, sebab tu kita dapat PV yang rendah lah kalau MV tu rendah. So a slower process response is indicated by shifting the process response curve to the right. So
Ada apa ni?
So basically dekat bahagian ini kita just nak explain je kenapa dapat PB tu when increase PB kenapa PV tu decrease. So you can use this statement lah kalau you nak buat conclusion ataupun discussion on effect of PB toward PV. So despite you faham dah kan? Ini just a summarize lah. A written summary. Boleh?
Faham. Boleh.
Okay. So kita pergi ke I. I pula. Okay, this one is a flow rate control. You boleh tengok dekat sini. The value of I change from 6 second to 12 second. So kita dekat sini kita tak perlu ikut step by step tadi, kita directly write down sebab you dah tahu. So PB tak ada changes only I is increased. So when I increase, the relationship between I and MV is inversely. That's why MV decrease. MV to PV is directly proportional. So MV decrease, PV will also decrease. So bila PV decrease, your response ni akan shift to the right. So you can read this sentence lah. You boleh guna this sentence when you discuss about effect of integral time towards process response. Boleh?
Boleh.
Faham kan? Straightforward je ni. Kena I baca satu-satu juga.
Faham.
Okay. So the last one this one. For the derivative. Okay. Dekat sini the PB, the D value is changed from 50 second to 75 second. Okay, we can say that the change occur only at D in increasing order because from 50 to 75. So increase of D would increase the MV because the relationship between D and MV is directly proportional. This one is directly proportional. So when MV increase, our PV also would increase because the relation is also directly proportional. So when PV increase, our response will shift to the left. Yang ni lah. You ada dua je yang you perlu tahu. PV decrease, maksudnya that process is slow. So masa yang diambil lagi lama. So dia akan shift to the right. Kalau PV increase, that process is fast. So kalau fast, masa yang diambil lebih cepat, lagi singkat. So that's why dia shift to the left. Boleh?
Boleh.
Okay, jom kita tengok lagi apa. So dah tak ada lah. Semua dah cover. Okay, dekat sini you boleh tengok juga summary ni dekat dalam buku ni. Kita ada there is a response yang dah buat adjustment on PB. So kita ada PB0 and PB1 and PB2. So sekarang ni the value of PB2 ni is 2 times PB1. PB1 is 2 times PB0. So you bayangkan kalau let's say you dapat value of PB0 is 100, then bila you multiply by 2, you dapat 200. So you akan dapat this kind of response lah. Your response tu akan shift lagi ke kanan. Bila you increase lagi value of PB, dia akan shift lagi to the right. Sebab you kena guna konsep when PB increase, PV decrease. That's why dia akan shift lagi lebih kanan. Masa yang diambil tu lagi lama lah untuk PV. Boleh?
Boleh, boleh.
Boleh. So same goes to I lah. Kalau I increase, sebab I dengan PB, the relationship with MV tu inversely proportional. So bila dia inversely proportional, dia akan, when we increasing the value of I and PV, it can cause the action of MV to slower. So when you get the slower action of MV, it will lead to the slower process response. So that's why you can see from here, I2 is double up from I1, I1 is double up from I0. Bila you increase the value of I, definitely the process will shift to the right. Boleh?
Boleh, boleh.
Okay, the last one, which is this one, derivative time. So derivative time macam you buat tadi, sebab derivative time towards PV is When D increase, PV would increase. Why? Because D is directly proportional to MV. When D increase, MV increase. MV increase, PV increase. So you can see that bila you increase the value of D, it will shift the response to the left. Dia lagi cepat lah. Boleh?
Boleh, madam.
Okay, so I think that's the end untuk buku ni. Linearity dulu pun kita dah belajar. Sekejap, I tengok balik dia punya content. So basically kita dah cover semua except performance analysis yang dekat bawah ni lah. Number 5 ni. Okay. So for the number 5 tu, wait we will cover during process response analysis. Supposedly in week 13 lah, week 13 and 14. So I rasa yang ni boleh habis cepat juga. Maybe week 13 kita boleh finish up the performance analysis ni lah. Okay. Ada soalan?
Okay, madam.
Tak ada soalan.
Tak ada
Tak ada soalan.
Semua faham
Faham.
Okay.
Faham juga.
Okay, good. So, I rasa kita boleh stop sampai sini dululah. So, we can end our class with tasbih kifarah dan sulawat as.